canceled out of it. Annoying. Wheels and tires. Cannon wheels. These. So as you can see, this is mounted at the 1, 2, 3, 4, 5. 2, 3. 1, 2, 3, 4. So you go back 4. 1, 2, 3, 4. So you're 1, 2, 3, 4. So it's 1, 2, 3, 4. Sorry about accounting. So press mate. You mate this with this here. So you need to consider the spatial distribution of the parts, essentially. So we need to rotate this. Rotate, rotate, rotate. Great. This works. And now you can see we have these two shafts together. So you can see they're very close for touching, but it's not touching. So good job, GoBuilda. You did pretty great on tolerances. So now let's insert the bevel gears. So these bevel gears, they can be installed freely on any shaft because they have like 2 screws on them that you can screw them in and fix them on the shaft. So as long as the shaft doesn't move, the melter gear does not move. But in this case, there are also 2 shims and spacers. So basically, it kind of wants you offset this gear to make sure it doesn't slide too by 8 millimeters. But technically speaking, you should be able to just, use screws to screw it in. But we'll just do this just in case. So let's import some shims and some spacers. So we need to use 2 0.5 millimeter ones. Like in the tutorial, you can import like a 1 millimeter one. I don't know why they don't do that, but let's do exactly the same as what's in it. So shaft spacers and shims, stainless steel shims, 8 miller ID. So these are all 8 miller RD ones, as you can see here. And yep. So we need 2 of these 0.5 ones. Great, and then let's do some spacers. As you can see, we do not have a shaft spacer here. Somehow, this is very ridiculous. So let's search up the part name. Or we can just CAD it ourselves if it doesn't show up. So since it doesn't show up here, we can just CAD it ourselves. It's a simple CAD. So internal diameter, the ID is 8 millimeters and the OD is 11 millimeters. So what we can do is we can create a part studio here, rename this spacer 8mm ID, 11mm OD, 9mm. Great. So let's just CAD this. Very easy. If you already know how to CAD, so choose a top plane and create a sketch, and then press C to do circles. You do 2 circles. One circle is 8, and the other is 11. I did not create this on the center point, and what you want to do, so it's blue, so you can see here it still can move. So you want to make sure it sticks to the center point. So, and then we can just very simply extrude this part by 9 millimeters. And great, that's done. And it's kind of ugly if it's blue, so let's just make this stainless steel color because it's stainless steel. Great. So now let's do this. Let's just mate this. With this here, because the spacers compress against the nearest bearing or end of a shaft. So this bearing is here. We attach the shim is here, and we attach the other shim. Normally in CAD you can just ignore this if you know what you're doing. Usually you don't really normally CAD shims or spacers, but sometimes you can if you need it. But in this case, you don't really need to do that. If you just bought these and they're lying around, then you don't really need to absolutely just insert them, because in reality it's not that important of a detail. So we can just insert this in. Great, this is the one we catted. So you can see here it's in the current document because this is where we catted it. And let's just make this in. Great. Now let's insert the melter gears, or the bevel gears. They can be called by both names. So they're in motion, gears, bevel gears, and I believe they are these. So what we can do is we go to our document, insert other documents, motion, and under motion we go to gears, bevel gears, melter gears, and then it's this one, 8mm Rex 1224 teeth. So this is the one that we need. So let's insert 2 of these. We need 2. Great. So normally we do not mate anything related to this hex part because it's very awkward. So we normally mate by the surface. So as you can see here, once we get to the surface, we can choose shift and you can choose this part. So as you can see, because the surface contains this semicircle here, so we can choose, so actually it shows up the center. After you press shift, it shows up the center of the thing, of the shaft basically. So you can press this and you have chosen the center of this face, essentially, this mating face. So what we do here is that we mate this with this here, and then we reverse direction. And as you can see, it's just very barely it's not touching this rod. So this is what we want. Okay, I just realized I made a little cat error here. Aw, dang, shucks. Which fastened is this? It's this fastened. Something went wrong. I did not make this thing the right way. So, if you're looking back, it should be the inner one, not the outer one. I accidentally selected the outer one. So, you do this. Great, now it's perfect. It fits. So, last step. Let's mate in this part. So as you can see, this part is in a very awkward position because there's no place you can actually normally just like mount this on the shaft. So what I'm going to do is a pretty awkward trick. So you can select the face here, like what we did before, mate, fastened, press shift, choose this, great. You have chosen the mating side, and then what we can do is that we can select this face here. Boom. And then you can see here, it's not actually mating with this. Oh wait, it actually is mating with this. This is exactly how it's designed to do. As you can maybe see, motion, wheels and tires, kind of wheels. Yeah, this actually just presses flush against that bearing. So hooray, we're done. So you can see there's like a bit of overlap here, but it's like not that important. A bit of overlap between these is just fine. But another fun thing we can do is that you can notice how this thing is rotatable. So you can rotate this. Or you should be able to rotate this. If you aren't, we can just change. Did I rotate this successfully? Let me see. Yeah, you can rotate this. And you can also rotate this too, because you can see it's connected to the center of the bearing, which is able to rotate. So, you can see here, you can still rotate this part too. You need to choose the correct axis. You can see, you can rotate this. So one thing you can do is actually you can add a gear relation. So you need to choose the actual revolute mates. So this is where the annoying part is. So where the hell are the revolute mates. So you'll probably need to select this, and then you choose the bearing and then say show mates. And you can see there's a revolute mate here. So this is the actual mate that's turning the thing. And then here, what you maybe want to do is maybe just highlight this part and also show revolute mates. Okay, you see the revolute mate here. So you select this 2, and the relation ratio is 1 to 1. So now you can rotate this. Oops, it turned in the wrong direction. That's stupid. So you can just reverse direction here. Yeah, now it's correct. Sometimes you can just like not bother to add this, but it's like pretty fun to do, like, you know. And I guess this is basically it. So these mates are here. It's pretty annoying. So you can highlight this thing and then the entire thing, and then just after you highlight the entire thing, you can just choose hide all mates, hide mates, and now it's pretty clean. So as you can see, it is almost nearly exactly the same thing as in this example here. So congratulations, you did this. Voila. We don't really need to insert the screws, but because it's not really that needed, but you can insert them with like this way, bolts and screws, socket head M4, and then you can say the length, maybe like 8 millimeters, and then you can insert them like this. But you don't need to do this. It just like adds complications, and then the more parts it is, the slower document it is. So like, imagine how many screws we use on an actual robot, like a couple hundred. You do not want to add these parts into like the CAD, because it just adds a couple hundred parts, and it just like slows in the entire process. But yep, this is it. So congratulations, you made 1/4 of a Mechanom drive.